And a go. Okay, look up please. Hey guys, come on. We'll have a look now at the next lesson. Look up please. Joshua, get off the wall please. I don't like you leaning against it. You look too relaxed. Yeah, in pain would be nice. Now, this next lesson, in the last lesson we saw the formula for the derivative using first principles. Okay? As you can see, it's a long process, and in fact there are quicker ways to calculate the derivative rather than using this formula. So what I'm going to do is I'm going to use the formula for something in general, like x power n. Then I'm going to see what the result is, and then I have a formula to get the derivative of x with a power. Okay? So, the derivative is x plus h power n minus x power n all over h. Using binomial theorem, or the C's, I have here nc0 xn plus nc1 xn minus 1 h plus nc2 xn minus 2 h squared, etc., minus x power n all over h. Now, what is nc0? Well, it doesn't matter because we know always what is the first term in our list when we expand. It's always 1. So this is really just 1. xn minus xn, they cancel. And if you look here, h cancels h. H squared becomes h, and then the next one will be h cubed, and that will become h squared. Yeah, so you're left with this. nc1 xn minus 1 plus nc2 xn minus 2 h plus, and so on and so on. It'll be, next one will be nc3 xn minus 3 h squared, and so on. But of course that's not finished. That needs to have its h go into 0. So if I put h to 0 now, what do I end up with? Well, it'll just be nc1 x power n minus 1. Well, what is nc1? If we remember the formula, it's n factorial over 1 factorial n minus 1 factorial xn minus 1. N factorial, that is n multiply n minus 1 multiply n minus 2, etc. 1 factorial, 1. N minus 1 factorial, n minus 1, n minus 2, etc. xn minus 1. A lot of things cancel here. And so you're left with this. So we have our result. If y equals xn, then that means its derivative is nx power n minus 1. And then that is our formula, which some people have seen before. Can't. So, let's try this with an example we did. I'm trying to think of one that we did. The first example I did was x cubed, wasn't it? Like at the start of the lesson in the first class. Was it x cubed? It was x cubed and I had 1, 1, didn't I? Yeah. And what did I get as the slope of the tangent in that one? 3. Yep. And then I did x squared. What was it? Was it x squared? No, I did x cubed first. But I did do x cubed. I remember doing x cubed. Huh? Yeah, so let's look at x cubed. So, if I have x cubed, what is its derivative? 3x squared. Now, if x is 1, what's 3 times 1 squared? 3. Which is the same answer that we got when we did it the other way. Yeah? So, what I'm saying is this formula, you could use this formula for all those examples that you did, and you get the same answer. But it's a lot quicker. Why is it a lot quicker? Because what I've done is, in the proof, that's what you would do in the last class. But we've skipped that proof out now in this class because we have a result, a general result. Okay? So the reason it's a lot quicker is because basically we're skipping this proof every time, that we have directly the answer. So let's look at some examples of how we can do this quickly. But before I do, let's just look at some special cases. For example, if x is 1. So for example, if we had y equals x, that's really the same thing as x power 1, isn't it? So if I use my rule, I bring down the power and then I take 1 away from the power, 0. What's x power 0? No, 1. And one more example, let's say I don't have x. Let's say I have a constant, like for example, 4. Yeah, well that's the same as 4x power 0, isn't it? Because x power 0 is 1. So here dy dx would be 4 times 0. Well actually we don't have to use 4, we can just make it easy for now. Let's just say 1. 1 is x0. So dy dx would be 0x0. 0x, what power here? Minus 1. But anyways, I multiply it by 0, so what do I have? 0. Now, what happens do you think if I have y equals k xn? Well, it's the exact same answer that I have there, except I multiply by k. Kn xn minus 1. So what I'm going to do is let me just put all those results together in a table. So don't worry too much about writing them down because I'm going to write them again now. So here we have fx and here we have dy dx. Or I'll use a different symbol now just so you're familiar with the different symbols. If you have a constant, its derivative is 0. If you have a constant by x, its derivative or its slope, of course, is k. But I mean, you knew that already, its slope is k. If I had kx power n, you'd have times k, x power n minus 1. Okay. We can use our formula fx plus h minus fx over h to find rules for other functions. We won't look at the proofs now, but I'll just give you the results. For example, if you had sine x and you use the first principles formula, you would end up getting cos x. The proof you can't do because you don't have enough trigonometry yet, but you will in semester 2. So don't worry about the proof, okay? And likewise, if you had cos x, its derivative is minus sine x. If you had tan x, its derivative is 1 over cos squared x. Okay, so that's the trigonometry ones. Now, there's some other ones too. You have exponentials. So, for example, if you had k, or actually let's keep the same letters, a, e, b, x. Its derivative is a, b, e, b, x. In other words, that b goes down in the front. By the way, special case, if a and b are both 1, what's the derivative here? What is it? Yeah. This is another reason why the e function is important, because it is the only function that has itself as its own derivative. No other function is the same after you find its derivative. By the way, if derivative is the noun, what's the verb to find the derivative? There's another one I'm thinking of which I prefer. Derivative. Yeah. It's a bit longer. Differentiate. I don't like using derive because I think another meaning of the word derive means to prove. Yes. So if you said derive, it could mean find the derivative, or it could mean prove it, or conclude. Yes, but differentiate always means, and only means really here, find the derivative. Okay, that's ex. The only function that has itself as its own derivative. Okay, what about log x? So, different color here. Log x. That's, you can't really see that. Let me use another color. Log x. Its derivative is 1 over x. What other functions have we done? So we have the x powers, we have sine, cos, tan, we have e and log. Is there anything else we've done? I don't think so. Yeah, we haven't done those, and we will look at those in semester 2. I think this is all of them. Sine, cos, tan, e, log, xn. What else is there? No, that's them all. So let's have a look at some examples. This table is very important. It's what you need for this worksheet today. Yeah, that's all you need. Okay, do you have that table? It's a very important table. Oh, I should also say here that no, it's okay, I won't say anything. Alright, I'm going to look at page 84, yes? Yes, that's what I'm going to do. How about root? So I'll do that in a moment, okay? Yeah, well, we'll look at that in a moment. Okay, so some examples. Let's say we have y equals x cubed plus x squared. What is the derivative? Derivative is 3x squared. So the power comes down and you take 1. Plus 2x power 1. That's it. I just used the table. So provided that you know how to read, you should have no problems with this question. Because you get this in the exam. The only difference in the exam is they would sometimes ask for a point as well. So in the question they might say something like, what is the slope of the tangent when x is 1? So here, what would be the answer? You have this in the exam, in section A, for 3 or 4 marks. Should be the easiest 3 or 4 marks in your life. Because this table here is in the formula book. So if you get less than 4% in the exam, I would be worried. Okay. Another example now. So that one's okay, but what do you do if you had something like a square root? So let's look at a square root example now. Can I scroll down? Yep. Is this finished? No, it's not. Okay. So let's say I have something like, whoops, not yet. Y equals square root x. What you do here is first you change this into a power. Then you can use the rule. So the rule is bring the power down and take 1 from the power. If you like, this can be rewritten as 1 over 2 root x. And then that's the answer. Again, let's put in a number in the question. So let's say we wanted when x is 1. So what would you get here? What's the answer? 1 over 2. Okay. Let's graph that now. Can I graph here? So can you tell me what was my first function I did? X cubed plus x squared, was it?
Yes.
And what was my point? Was it 1? What was my value for x? It was 1, was it? And what did we get for the slope then? 5. So let's see if we get the same answer if the computer does it. So 1. So what is the equation of the tangent line? It feels very Star Trek. I feel like I should be saying to the computer, give me the equation of the tangent line, please. Or Siri maybe or something. Right, what's gone wrong here? I have to calculate it first. Okay. Equals? And what's the slope of this line? 5, which is what you got. Okay, so let's do the square root one now. So, square root x, graph that. There's the graph of it there. Okay, now time for tangent line. Tangent square root x when x is, did I use 1 again? Yes? Okay. Yeah, what's the slope of this line? A half, and what did you get? A half as well, and let's graph it as well. And there's the tangent line there at 1. So you can see now that you have your table, it's a very quick process to calculate slopes on curves, slopes of tangent lines. Okay? I didn't actually say it, I just did it, but it actually is true that, I'll make it explicit here, that if you have one function plus another function and you want the slope, then, or sorry, if you want the derivative, then you use the tables on the first one plus the tables on the second one. Well, that's what I did here. Okay, so I just looked in the tables for here and here.
Will you give us the example the derivative of the derivative?
Yeah. Yeah.
X of g from
Yes, you could get that, yeah. Second derivative, yeah. Let's do another example here. So let's say y equals ex plus sine x. I would like everybody to tell me what the derivative is here. Look at the table book, what do we got? Ex plus cos x. Okay, I'll give you one to try now. So I want you to try this one. Y equals ex plus cos x plus x. And I would like you to calculate for me. I want to know what is the slope of the tangent when x is 1.
I'll see what the answer should be.
One second. What you got? Anyone else?
2.7.
What?
3.7.
2.7? Yes.
2.7.
Yes, 3.7? What did you get? 2.7?
2.7.
Don't forget about the minus. Hanish, did you have a minus? Yeah. Now, listen. Hanish, Daniel, listen. Some people are getting 3 point something, and some people are getting 2 point something. The correct answer is, which is the 2 or the 3? What do you think? It's 2. Why is it radians? Huh? Why is it radians? Tell him. Ali doesn't know. Explain to him.
I did it in radian.
She's right. When I wrote the x, did I put a circle on it? No. So it is radians, not degrees. And besides which, you should remember 2 weeks ago I said, what is the default mode? Radians. Unless there's something in the question that says it's degrees. Anything here that says that? Nope. No. So don't make that mistake in the exam. You're just throwing away marks. Catches people out every year. Okay, but no, not this year. Okay. So you should be able to do number 1 and number 2 now. So let's have a quick look at number 3. Okay. So for example, let's do 3a. I have 9x plus y minus 3 equals 0. Come on, look up. And what would I like to calculate here? dy dx. So before I do that, I need to find what the y is. So here you get y equals minus 9x plus 3. Isn't that right? Yeah. Minus, yeah. So what's dy dx here? Minus 9. Because this is 0 and then this is on the table book. But suppose I change this now. So that's what we were asked for. But let's imagine now I was told 9x plus y minus 3 equals 0 and I want dx dy. It's not much different. Yeah, you need to imagine on your graph that the x is vertical and the y is horizontal. That, in other words, you're just renaming what you call x, you call y, and what you call y, you call x. So here you would get 9x equals minus y plus 3. So what does x equal? Minus 1 over 9y plus 1 over 3. So then what would dx dy equal? Minus 1 over 9. Now look at this answer and look at this answer. They're very, very similar, aren't they? In fact, the only difference is what? The second answer is 1 over the first answer. And that's the key thing here I want you to learn. That dx dy is in fact the same thing as 1 over dy dx. Now this is getting interesting because think back to when was the last time that you saw a slope that you have to turn upside down? When did you last do that? Perpendicular. Tangent line. Does anyone know the name of what's perpendicular to the tangent? It's normal. It's called the normal. So in fact what we have now is this. dy dx is the slope of the tangent, and then minus dx dy, that is the slope of the normal.
Minus, do it all.
Yeah, because remember when you want to make it perpendicular, you flip it upside down and change the sign. So this here isn't quite the slope of the normal because it has, this should have been positive 1 over 9, yeah. The reason I'm drawing your attention to this fact is that once a lot of students were caught out because the question said, what is dx dy? And the students found dy dx. And they forgot at the end to flip their answer upside down. That they weren't reading carefully. That they didn't see it said dx dy. So the whole reason I have number 3 there is just for you to recognize when you have to flip and not flip at the end. No, don't change the sign. Because it just said dx dy. It didn't say slope of normal. If it said slope of normal, then yes, change the sign too. So take care. It will probably say dy dx in the exam, but if it said dx dy, flip the answer at the end. No, you just asked me that 10 seconds ago. Don't change the sign unless they said slope of normal. Then you change the sign. But if they just said dx dy, that is dy dx flip, and that's it. Okay. If they said slope of tangent, what's slope of tangent? Dy dx. And what's slope of normal? Minus dx dy. Or in other words, minus 1 over dy dx. Take care. Okay? Right. What I'd like you to do, because these are really, really short, like they should only take 30 seconds maximum per question, I'll give you the last, number 1, 2, and 3, the last 5. Last 5. 1, 2, 3. Okay. What's that? Optional, if you feel brave enough. What could possibly go wrong? Okay, start them now, please. Okay.